is a video I'm making on unit analysis. When we talk about algebraic explorations, a lot of the time we're writing number sentences that involve units. This could be things like meters, grams, dollars. It could also be rates. We have feet per second, miles per hour, pesos per dollar. If you wanted to do some type of conversion, those are handy as well. But we use units all the time. So just to make sure that we're good on units, a couple of things. First things first, we perform these ones right here, but we want to make sure we label with appropriate units, and that way we can tell what we had been working with to begin with. And plus, it helps you to, helps to remind you what you had been dealing with in the first place, some type of context. You're not just doing some math problem. So, for example, if we were to add miles plus miles, we would get miles. Of course, 235 plus 75. Let's see here. We say 235 plus 75. We'll take the short way here. I get 310. 310. So we have 310, and then down here we'd have a half plus 3/4, which is the same thing as 2/4 plus 3/4, which is 5/4. So we'd say 310 and 5/4, and this would be miles. And of course we would want to rewrite this as 311 and 1/4 miles. But the point here being that we need to label it. Okay, so you might think, well, that was easy, like you seriously need to do an example of that, but really it's the next one that I'm concerned with, is when we start to do conversions. So when we talk about units, it's important that we're actually labeling our values in, say, a word problem, because units cancel out. So as a matter of like an example, we say, well, 3.5 hours times 60 miles per hour. Okay, you notice that I have everything labeled with units here, and I also want to mention this, we're multiplying fractions here on the left side of this, and I can say this because we can put a 1 underneath it. But the thing I want us to recognize is this: if you were to multiply fractions, you do it straight across. So 3.5 over 1 times 60 over 1 would be 3.5 times 60 over 1. Okay, so we'd have 180 plus another 30 is 210 over 1. But the other important thing to remember here is this: we're multiplying units. So on the top, I would have gotten hours times miles. And this seems really awkward, but I get hours miles on top. Okay, so hours miles, 210 hours miles over 1, and on the bottom I noticed I took 1 times 1 hour, so I got an hour. And the interesting thing about this is that our hours, see, they cancel out. Okay, and we could have done that over here. We could say, well, this had an hours on it, and you multiply straight across, but I know that once I do, these hours are going to cancel out, and what you get left with is just miles. Okay, so in this case we'd be left with 210 miles. We didn't have to do much with the numbers, we just multiplied those, but the reason why is because these hours canceled out. So going down here, let's go ahead and take a look at this. We've got a lot of multiplication to do straight across. That's how fractions work. So we'll do the top and the bottom. As a matter of fact, the bottom, 1 times 1 times 1 is 1. On the top, 50 times 60 times 60. Suppose we could do this here. We could say 50 times 60 times 60, and we get 180,000. So we get 180,000. But this time, what I want to be able to do, instead of writing feet, seconds, minutes over seconds, minutes, hours, and then reducing, what we'll do is we'll reduce right up front. So for example, I see feet on top here. Are there any feet on bottom it cancels out with? In this case, no. How about seconds? Well, I notice that seconds here and seconds here cancel out. I also notice that minutes down here and minutes up here cancel out. And what we're left with are these two units here, feet and hours. So we get this, and we could even write it as this: feet per hour off to the side. Or we could write 180,000 feet over 1 hour. These are going to both mean the same thing. Okay, so units wise, let's keep that in mind, that we have to write those out, and the reason why is because we're going to do some conversions now. So conversions, it's useful to be able to convert from, like, say, feet to miles, or feet to yards, or seconds to hours, pounds to kilograms. So in an effort to do so, what we're going to do is we're going to borrow from a really simple property of algebra. It's called the multiplicative identity property. And it says anything times 1. A times 1 is itself. So what we are attempting to do a lot of the time is convert from one unit to another by using this property. And here's how this works. Okay, we'll just go ahead and take a look at example A over here. We want to convert the following measurements to the desired units, and I want to convert 150 pounds to kilograms. Okay, so we are going to use what you may have heard is what was called the train tracks method. Okay, and train tracks, because they look like, when you write it out here, it looks like train tracks, kind of. Okay, so you're always going to start with what you're given, and in this case we say given. My very first thing in the train tracks here is this. I've got 150 pounds. Now 150 pounds, I write like this. We always want to convert it to a fraction first. So I was given 150 pounds over 1. Okay. Now that I've got written down what I want, or what I have given, I'm going to write down what I want. So I want kilograms. So want. Okay. And we're going to write this. We say how many kilograms over 1. And what we're trying to do now, if we extend the train tracks over here, is this. I don't know how long these train tracks are going to need to be, but I know what I'm starting with, and I know what I want to end with. Okay, so we're going to have to piece together some information, and keep in mind I'm coming back to this property here, but 150 pounds, how do pounds compare to kilograms? And this is where we have to go look up what we call a conversion factor. So a conversion factor. Now, conversion factors are pretty spiffy here, and I want to kind of point out the one we're looking at. I notice the one that converts or relates pounds to kilograms happens to be this one right here, and it says 2.2 pounds per 1 kilogram. What I want to write down is this, of course. We could say this. We could say 1 kilogram over 1 kilogram. That's just 1. That's itself. That equals 1. Okay, I'll go back over here and point this out. If I were to change this now to 2.2 pounds over 1 kilogram. The thing I want to mention is this. 2.2 pounds is the same thing as 1 kilogram. So to write 1 kilogram over 1 kilogram, we mean 1. Then to write 2.2 pounds over 1 kilogram, all of this also means 1. Okay? And the reason why that's so nifty is because of this. I am going to take 150 pounds, and I'm either going to multiply by 2.2 pounds over 1 kilogram, or I'm going to multiply by 1 kilogram over 2.2 pounds. Okay? And the thing to keep in mind here is this. Both of these mean 1. So when I take this 150 pounds times either of these quantities, I'm really taking it times 1, which doesn't change the fact that we have what we started with. Okay, so our job is to change 150 pounds, not the fact that it is 150 pounds, but change the way it looks as a number. And so we're going to multiply by 1 systematically. So here's our deal. We're going to take 150 pounds times either of these quantities because they mean the same thing and they mean 1. So we say, do I want to multiply by 2.2 pounds over 1 kilogram or 1 kilogram over 2.2 pounds if they mean the same thing? And keep in mind, we want to get left with kilograms on top and we want our pounds to go away. We don't have any pounds left here. So both the things I can multiply by, I'm going to choose to multiply by 1 kilogram over 2.2 pounds. And let me tell you why. The reason why is because look what just happened. We got our pounds to cancel out, and look what you're left with is the thing that we wanted. Okay, so on top we have 150 times 1, so this would be 150, and on bottom we have 1 times 2.2, so we get 2.2, and we're left with this 150 kilograms over 2.2. Now, the entirely appropriate thing to do would be this: grab a calculator and say 150 divided by 2.2. But we get 68.18 repeating, so we could say this is the same thing equals 68.18. The 18 repeats, and we're going to write our units, which is kilograms. So 68.18 kilograms, same thing as 150 pounds. So now we're going to work with a couple of other ones here and then be done with this video. We say convert 20 feet per second to miles per hour. We're going to do this quicker this time. We say train tracks. We say I'm given 20 feet 1 second. We say, well, what do I want to get? I want to get miles over hours. Okay, and we don't know what these are yet, but we know train tracks. Let's get our train tracks rocking here all the way across. What we want to do is we want to find how can we relate feet and seconds to miles and hours. So first things first, how about feet in miles? Okay, so we say feet in miles. Where's that at? I look over here, we say feet in miles. I know there's 5,280 feet in 1 mile. So we're either going to multiply by this, 52,080 feet in 1 mile, or we're going to multiply by 1 mile over 5280 feet. And the question is, which one gets rid of the units that I want to get rid of here? Well, I want to go to miles, so I want miles, and I don't want feet. So if I'm going to multiply this by something that's going to get my feet to cancel out, we're going to multiply by 1 mile over 5280 feet. The reason being is because instantly I can see that those things cancel out. Now I'm left with miles per second. I want miles per hour. So I say, well, how am I going to get this into hours? Well, how do seconds relate to hours? We say seconds and hours. We know that there are 3,600 seconds in an hour. So I'm either going to multiply by 3,600 seconds over 1 hour, or 1 hour was 3,600 seconds. And it seems to me in this case I want 3,600 seconds over 1 hour. And the reason why is because now my seconds are gone. And you notice what we're left with in terms of units here. You know when you're right because you're left with your miles per hour that you wanted in the first place. So now we just need to multiply straight across 20 times 1 times 3,600. So we get 20 times 3,600, because anything times 1 is itself. We get 72,000, so 72,000 miles. And in the basement, 1 times 5280 is 5280. So we get 7200. We'll divide this by 5280, and we get this 13.63 repeating. So this is approximately 13.63 repeating, and we have miles per hour. So this last one down here, euros, $120 to euros, and we have an exchange rate here I just gave us. So we say 3/4 of a euro per dollar. So let's go ahead and write down what we're given. We have $120. Oops, let's erase that there. $120, we're going to put this over 1. We say this is what we're given. We want to be left with euros. So euros, how many over 1? Let's make our train tracks here. We don't have to have the roof here, but basically let's make this. And we know that the conversion rate is 0.75 euros per dollar. So I want my dollars to go away. I want to be left with euros. Okay, so we're going to multiply either by 0.75 euros over $1 or $1 over 0.75 euros, and it makes the most sense to have the $1 down here because my dollar is going to cancel out. So we have 0.75 euros. Our dollars are canceled out now. We can multiply straight across. So 120 times 3/4, that's going to come out to be 90, just to be quick about it. But that is how you would do conversions. Cheers.